Hey y'all, I'm here with the 2023 AB Calculus FRQs. I'm about to do all 6 of them. The first one is some sort of rate question with a table. They ask you about what this integral means. Well, if we're doing a rate times time, that's going to be the number of gallons of gas that floated in the tank from time 60 to 135. You do the Riemann sum. The only thing is tricky there is it's 60 to 135, so it's only 3 subintervals, and you should have gotten 8.25 gallons. Second question asking you, is there a spot where f prime equals 0? Well, this is a mean value theorem question, but with the mean value theorem, you got to show that the average rate of change equals 0 first, state that f is differentiable and therefore continuous, and then with the mean value theorem, it is true. Part C asks for an average rate, flow rate. Well, your average value of G is what that's asking for. So you do the integral divided by the integral for your average value. And the units should still be in gallons per second. Part D asks us for G prime of 40 and then interpret what that means. And so G prime of 40, that is just the derivative. We're going to use math 8 and get that value from our calculator. The units are going to end up being in gallons per second. And it tells us at time equals 40, since this is negative, the rate by which gas is flowing into the tank is decreasing by 0.05 gallons per second. Important thing, make sure you mention that this is happening at 140 and decreasing. That's what that derivative tells you. All right, question 2 is your motion question. So it gives us some sort of velocity equation that we're going to put in our calculator. And it says find all times where the kid changes directions. Well, he changes direction when his velocity is 0 and his velocity changes signs, and that occurs at time equals 56. And I already put seconds in there. Second one, find the acceleration at time 60. And then tell me whether he's speeding up or slowing down. So we can use math 8 in order to do that. And you should have units of meters per second squared. We also want to go ahead and find the velocity at time 60 so we can see if the velocity and acceleration are the same signs or opposite signs. They turn out to be the same sign, so he is speeding up because the acceleration and velocity at time 60 are the same signs. This next one is find what is the distance between his position at 20 and 80. There's a couple ways to do this one. I think the easiest way is just find the displacement from 20 to 80, and that's your change in position. And so if you do that, you end up finding out it's 23.384 meters. You could have assumed a position of 0 at time equals 0 and found the position at 20 and found the position at 80 and then subtracted the two. That would get you the same answer, and that's a valid way to do it. But this, I believe, is your simplest. And then total distance, remember your total distance is your integral of the absolute value of the velocity from 0 to 90. And you do that, and you're getting 62 meters. All right, question 3. This question seems very similar to the potato question that vexed a bunch of students a few years back. And so this is milk being cool, coming out of a refrigerator, I believe, and warming up this time. And so it gives you a differential equation. It gives you initial temperature. Asks us to draw the solution curve. So we just follow the slope field, and hopefully you got a horizontal asymptote there at 40. Second one, come up with a tangent line. If we're doing a tangent line, we're going to start with our point slope. Use that. It gave us the point already. Our slope is going to be what happens when we plug into that differential equation. And so we do that. We end up plugging in 5 into our differential equation. We end up getting 35 over 4. We plug into our point slope formula, and we end up getting and plug in 2 in for x, and we end up finding out that it's going to be about 45 over 2 degrees Celsius. Find the second derivative. All right, so the first thing I do is I distribute that 1/4, make it a little easier on ourselves to find the second derivative. We find the derivative, we have to remember that the derivative of m is dm dt. So we need to substitute dm dt back into that equation right there, and we find out we end up getting negative 1/16 times this 40 minus m, which will always be 0 because it told us the temperature of the milk is never going to be more than 40. And so we end up knowing that that means the graph is concave down and our tangent line will be an over approximation. But really all you need to say is dm dt is always negative, therefore it's an over approximation. Part D, this is where we're solving for the particular solution of the differential equation. And it even gives you a big clue there. It says separation of variables. If you miss that, well, that's a big clue. You should have known what to do. So we're going to go ahead and separate our variables. Take the antiderivative of both sides of this. Remembering you have a simple u sub and you have that negative there from the derivative of the inside function. I prefer, instead of plugging in immediately to solve for c, I like to get rid of this natural log first. So I went ahead and divided by -1 and then exponentiated both sides with e. When I do that, that minus c becomes that coefficient k, and it's much easier to solve for. Plug in to this equation, we can end up getting that k value equals 35, and ultimately this would be your solution. There are many other solutions that are also valid, but I believe this is probably the cleanest. All right, on to question 4. Question 4 is your f prime graph analysis question. And so it's asking us at 6, is there a relative max or min? Well, at 6, there is neither a max or min because the graph of f prime does not change signs. So that's pretty much what's happening there. B, on what intervals is the graph of f concave down? So we're looking for f prime is decreasing. So f prime is decreasing from -2 to 0 and from 4 to 6. Part C, it's a limit. It's probably L'Hopital's rule. You can see if it is by just plugging in 2 and seeing if you get 0 over 0, and we do get 0 over 0. You need to make sure you show that. That is the condition of L'Hopital's rule. And then you take the derivative of the numerator and the denominator, and we get this, and we plug in 2 into that, or take that, find that limit. So we've basically found the equivalent limit using L'Hopital's rule, and we should have gotten 3. Part D, ask for an absolute minimum. We do that. We're going to be using the candidate test. Make sure you explain why you chose the candidates you did. F prime changed from negative to positive, and the endpoints. So those are our 3 candidates. It gave us, f of 2. And then with a little bit of area addition, we can figure out the value at 8. And a little area subtraction, we can figure out the value at -2. And it turns out f of 2 equals -1 is your minimum. Hopefully you did not say the minimum was x equals 2, because that is not what the question's asking. On question 5, this is a lot of derivative rules and integration, just being able to read math kind of. So in this first question, it just really wanted us to use the chain rule to figure out what is h prime of 7. So we need to use our chain rule, derivative of the outer function, the inner one still plugged in, times the inside function, and you end up getting 12. On part B, it asks us if this function k it gives you is concave up or concave down. Well, the second derivative is going to tell us that. It's already giving us the first derivative, so we need to find the derivative of that. Well, this got a little bit of chain rule here, so take the derivative of f of x squared. It's going to be 2f of x, f prime of x, times g, plus the derivative of the second, which is g prime, times f of x squared. And then it's just a matter of plugging in and getting those values from the table. You're also hopefully realize you could just leave your answer like that and you don't need to go further. Well, maybe you do. I don't know. You might need to actually figure out whether this is positive or negative. So we're going to take it's concave down because k prime of 4 was less than 0. So you need to make sure you drew that conclusion and you connected the dots. You didn't just show -40 and then say k is concave down. You need to make sure you tell them why it's concave down. It's because that second derivative was negative. On the next question, it's just a matter of plugging 2 in, just like Algebra 1, We're just going to replace all the x's with 2, and so we do that. This portion of it is just going to be 40. We have an integral to solve. The antiderivative at the upper bound minus lower bound, so the antiderivative of f prime is f of x, so it's just going to be f of 2 minus f of 0, and hoping you got 37 when you did that. Next question asks you whether your value at 2 is increasing or decreasing. So we need to look at the derivative to tell us whether the derivative is positive or negative. And so we find the derivative of m. You take the derivative of the 5x cubed just like you normally would with the power rule, and then you use the second fundamental theorem to find the derivative of that integral defined function part, and that's just going to be f prime of x, and then you plug in 2 and you should get 52, so therefore m is increasing because m prime is greater than 0. On to question 6. This one was very tricky for students 2 years ago when they asked this question. And so if you studied your past FRQs, this one should look very familiar. It asks you to find this dy dx. It should show that this is true. And so it's just basically doing implicit differentiation with that, making sure you use the product rule for that 6xy, and then your derivative of y cubed. You got to make sure you multiply times the derivative of the inside function dy dx. Then you go through and you solve for dy dx by getting all dy dx's together, factoring, and then dividing. And ultimately, you can show that it comes there. The next question it shows us, find the coordinate on the curve for which the coordinate has a horizontal tangent line, or explain why it doesn't exist. Well, if you have a horizontal tangent line, you have a slope of 0, so your dy dx needs to equal 0. And the only way for this fraction up here to equal 0 is if the numerator equals 0. So you need to have 2y equals 0, which means y equals 0. Well, when you plug y equals 0 back into the original equation, you get 0 equals 2, which tells us there is no point where y equals 0, and therefore no point where the slope would equal 0. So there is no point where there is a horizontal tangent line on this curve. Question C. You're looking for where dy dx is undefined. Well, dy dx is undefined when the denominator is going to equal 0. And so you solve that, and you can't really solve it for a value because you have two variables and one equation. So if you remember back from Algebra 2, you need two variables. If you have two variables to solve for, you need two equations. So we're going to go ahead and just get a relationship between y and x right here by solving for x. And I'm going to plug that and substitute out the x value in our original curve. So I'm going to replace this x that was right here with y squared over 2. And now we can solve for y. We get y equals 1, in which case we can plug the 1 back into this y squared over 2. And we end up finding 1 squared over 2 is 1/2, and so you get the point 1/2 comma 1. And then lastly, it's a related rate question. It's telling you the rate at which some particle is traveling along this curve. It says, what is the value of dy dt, the horizontal rate or horizontal velocity of this particle. So all I did was I just took the derivative of our curve with respect to time using implicit differentiation or related rates, took the derivative with respect to time, and so there is my derivative right there. And then all my dx dt's, I just plugged in the 2/3 into that and solved for dy dt. And when I did that, I ended up getting -8/9, and that was in units per second. Well, hopefully you found those answers useful. Hopefully you got all those answers, and I wish you the best of luck on your AP scores when they come back in July.